Alright, section 4.9, solving polynomial inequalities. Today we'll be doing something very similar to what we've been doing the last couple of days. The only difference, no more equal sign. Because equal sign is for people that like black and white. But we like to delve into gray areas. We like uncertainty. Alright, how do we solve polynomial inequalities? We probably should figure out what a polynomial inequality is. Well, it's an inequality that is equivalent. Right, good word choice there. That is equivalent to an inequality with a polynomial as one side and as 0 as the other side. All this basically means is it's going to look very similar to what we've been doing the last few days, but instead of an equal sign, you're going to have a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign. Now, to solve these, we're going to use the same steps that we used before. You're going to move all the terms to one side, which leaves a 0 on the other side. You're going to factor just like you did before. You're going to factor into linear factors and apply one of the following. The product of a times b, or if more, a times b times c, is greater than 0 if and only if a and b have the same sign. So a times b is greater than 0 only if a and b are both positive or both negative. Meanwhile, a times b is less than 0 if and only if a and b have opposite signs. So, again, you have to remember that when you multiply two numbers with the same sign, you're always going to get a positive number. If you multiply two numbers with opposite signs, you're always going to get a negative number. Alright, so let's see how this works. Example 1. Find and graph the solution set to x minus 4 times x plus 2 is less than 0. So, because the inequality has a less than sign, you're going to want the product of the linear factors to be negative, so these two must have opposite signs. So let's consider the possibility first that this first term is positive. X minus 4 is positive when x is greater than 4. If this is positive, then we need the x plus 2 to be negative. That's true when x is less than negative 2. So with x's in this range, we will have a positive and a negative. Now we'll consider that if the x minus 4 is negative, in other words, if x is less than 4, this part has to be positive, which means x is greater than negative 2. Now you have two conjunctions here with an or in between, so you need both of these to be true. Well, there are no x's that are both greater than 4 and less than negative 2. But there are x's in between negative 2 and 4. So your solution set is x is such that negative 2 is less than x is less than 4. To plot this, just like you did before, if you have a less than sign, you use open circles. Put them at the ends, negative 2 and 4, and connect the points in between. So again, check the inequality. This will tell you what the product has to equal. Then consider all the situations, whether x is greater than 4, x is less than 4, x is greater than 2, negative 2, x is less than negative 2. You will notice that these numbers here work out as the zeros if this were an equation. So these are kind of be the critical values, and you'll be looking at that later on. Alright, example 2. Find and graph the solution set to y squared minus 3y is less than or equal to 0. So the first thing you're going to do is factor just like you did before. So we'll factor out a y, and we get y times y minus 3 is less than or equal to 0. So since the product of the linear factors is negative or 0, then the signs have to be opposite. So if y is positive, in other words, if y is greater than 0, then this term is positive. This quantity has to be negative, which means y has to be less than or equal to 3. If y is negative, y is less than or equal to 0, then this term is negative. This y minus 3 term has to be positive because it has to have an opposite sign. So in this case, y would have to be greater than or equal to 3. So now we look for y's that are in satisfy both sides. So are there any y's greater than 0 and less than 3? Why, yes, there are. 0 is less than or equal to y is less than or equal to 3. This one has no solution because you can't have a y that's both less than or equal to 0 and greater than or equal to 3. So the solution set is 0 is less than or equal to y is less than or equal to 3. Now to plot this, you would put filled circles as the zeros, 0 and 3, because it's a less than or equal to sign, and connect the points in between. So again, make sure you check the product, make sure the signs match what the inequality is asking for. Alright, example 3. Find and graph the solution set to 4k squared minus 8k is greater than 0. So go ahead and try this one. It's very similar to what we just did, but make sure you take note of the sign. So the first thing you want to do is divide by 4, because when you have an inequality or inequality, you don't have to factor out the 4. You can divide both sides by 4, because 0 divided by anything is going to be 0. So you're left with now k squared minus 2k is greater than 0. So now we factor out a k. K times k minus 2 is greater than 0. Because we have a greater than sign, the signs of both k and k minus 2 must be the same. So if k is positive, in other words, if k is greater than 0, then this one also has to be positive and k has to be greater than 2. Or if k is negative, this quantity k minus 2 must also be negative. That's true when k is less than 2. So take both ands, let's see what we get. K is greater than 0 and k is greater than 2 when k is greater than 2. K is less than 0 and k is less than 2 when k is less than 0. So you're going to plot these. There's your solution set. K is such that k is greater than 2 or k is less than 0. Put open circles at 0 and 2. Put 0 and you're going to go to the left because k is less than 0. Put 2, k is going to go to the right because it's greater than 2. So when you have a greater than sign, you're often going to see this type of pattern where you're going to have two rays going outward from the zeros. Sign graphs. You can check your work by choosing a test point on the number line. A sign graph is used to help find and graph the solution set of a polynomial inequality. This is really helpful when there are 3 or more factors. Now, the book way has one way to do it, then I'm going to show you the way that I learned how to do it, and I think my way is easier. You can use my way instead of the book way, even on the simple ones. And the way that I do it, you can always use. It's simple, and you'll see how it works. But we'll go through the book way first because some of you want to use the book way. Example 4. Find and graph the solution set to y cubed minus 16y is greater than or equal to 0. So the first thing you'll want to do is factor out the y. So you have y times y squared minus 16 is greater than or equal to 0. Then you're going to need to factor this out as a difference of squares. So you get y times y plus 4 times y minus 4 is greater than or equal to 0. Alright, to draw a sign graph, you're going to have to draw a number line for each factor. I know this sounds really exciting already. And label the part where the factor is positive, 0, or negative. Alright, you're going to see very quickly why you're not going to want to do this, but humor me, humor the book. Here we go. Now, there's a number line for all 3 factors. Where is y 0? It's 0. Alright, so we put a dot at 0 because it's an equal than sign. Greater than equal to than sign. So you want to look to see where y will be positive, negative, and 0. So you can put negative signs there, a 0 there, and a positive signs there. You're going to do the same for y plus 4. So you're going to put a filled circle at negative 4, and below negative 4, this quantity, y plus 4, is going to be negative, and above negative 4, it's going to be positive. You'll repeat that for y minus 4. So you're going to put a filled circle at 4 and do the same thing. So that's step 1. Do a number line for each one. Again, you're not going to want to do this, but follow along anyway. Now, the sign of the product is determined by its negative factors. If there is an odd number of negative factors, the product is going to be negative. If there is an even number of negative factors like 0, 2, 4, etc., then the answer is positive because all those negative factors will cancel each other out. Alright, so here we go. You see the solution set below? There's the product. You put the zeros down again. Negative 4, 0, and 4. And you want to kind of look down. So you see a negative, negative, negative. You see a negative, positive, negative, which is positive. A positive, positive, negative, which is negative. And a positive, 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 which is positive. So what you end up with in this sign graph is the areas where the product is negative, positive, negative, and positive. Since we need the area to be positive, we graph this area here between negative 4 and 0, and we graph this area to the right of 4. So the solution set is x is such that negative 4 is less than or equal to x is less than or equal to 0, or x is greater than or equal to 4. Alright, so the sign graph basically has you line them up and do that. Look, you're not going to want to do this. Alright, so this is the way I'm going to tell you how to do it. Mark the roots either open or closed depending on whether it's a greater than or equal to sign or a greater than sign, etc. And see if each term is positive or negative in each range. Alright, so in this case, we need the term to be positive because it's a greater than or equal to sign. So we have to have an even number of negative terms. That's always going to be true when you're looking for a greater than 0. So here are the zeros. We have y equals 0. We have y equals -4. We have y equals 4. Now, this is what you do. When y is less than -4, what is y? Well, it's negative. This is also going to be negative. You plug in -5. -5 plus 4 is -1. You plug in -5. -5 minus 4 is -9. So you're going to get 3 negative signs. All 3 of those are negative. Now, let's go from the range between -4 and 0. If you want to plug in -2, you can do that. So let's plug in -2. -2, that's negative. -2 plus 4, well, that's positive. -2 minus 4, that's still negative. So now we have a negative, positive, negative. And you will see a pattern. Between 0 and 4, now you're going to have 2 positives and a negative. And above 4, you're going to have all 3 terms positive. Now you want the areas where there is an even number of negatives. So that's between -4 and 0 and greater than or equal to 4. And you're going to graph those sections that are positive. All right? So the solution set here, y such that -4 is less than or equal to y is less than or equal to 0, or y is greater than or equal to 4. So you can do it the book way, which if you want to rewatch, you can, or you can do it the way that I know how to do it. Basically, put the zeros down, use open or filled circles depending on the sign, and then just look at the terms in this range. Is it going to be negative or positive? And just do plus or minus for each factor. And make sure the number of factors equals the number of negatives and positives. Alright, finally, example 5. Find and graph the solution set to y minus 1 times y plus 1 is less than y plus 1. Alright, so the way you do this is you have to multiply and simplify. Now, you might be tempted to say, I'm going to divide both sides by y plus 1 and make that disappear. You can't do that. If you do that, you're going to lose one of the factors. So you're going to have to multiply out this quadratic and simplify. But that's not too bad because it's a difference of squares. So we have y squared minus 1 is less than y plus 1. Remember the next step. Move everything over to one side. So I'm moving the y plus 1 to the left. So you end up with y squared minus y minus 2 is less than 0. Alright, finally you're going to factor that. So that factors nicely into y minus 2 times y plus 1 is less than 0. Alright, so let's do my way because I like my way. First step is to fill the zeros on the numbered line. So our zeros here are going to be 2 and -1. Because we have a less than sign, they're going to be open circles. So there's an open circle at -1 and 2. Now, you're going to look for opposite signs. We have two products. You want the product to be negative, so we're going to need opposite signs. So when y is less than -1, both terms are going to be negative. When y is between -1 and 2, one's going to be positive and one's going to be negative, and above 2 they're both going to be positive. And again, if you're not sure why this works, just plug in a number from one of these zones and you'll see very quickly what will happen. So since we need opposite signs, we're going to plot in between -1 and 2. The solution set is y is such that -1 is less than y is less than 2. So you can use this way for all the homework problems, for all the problems you do. You don't have to do the book way. You don't have to do it this way. This way works perfectly fine, and I'm happy with it. I've had students with success doing it this way, and hopefully it works for you too. So that ends 4-9. We'll have some problems tomorrow in class. If you have any questions in the meantime, hit me up on Facebook or an email.